Here we got a college algebra 1710 part 2 video here of the practice final. Again, you can work ahead of me, pause if you want to. I'm going to try to go through these as quick as I can. First one here, number 33, they asked you to determine if that ordered pair is a solution to the system of equation. A couple ways you can do this. You can actually, if you wanted to do matrices, you could do an RREF on your matrix. And as we do our 3x4 matrix, and you can see, does it come out to be, sorry, there we go. Hard to see the minus signs with my glasses here. And if we did that, we can say, okay, what does it spit out for an answer? That's one way you can do it. The other way you can go through is you can start putting the, this would be your X, Y, Z, and just put them in there and see, okay, does it balance all three of those? And so either method works. And, I'm going to go quickly through just putting the numbers in and balancing. If I go 2 plus 9 is 11, minus 4 is 7, so it does balance that one. Then I go 2 times 2 is 4, and then negative 5 times 9 is a negative 45. And then I have a negative 9, so 4 minus 45, negative 9 times negative 4 is a plus 36. That becomes 4w and negative 5. That worked. Then I try the last one here, and I say, okay, 2 times 3 is 6, and then I have a minus 9, and then a minus 20. So that's a positive 5, and we have a negative 4. So that would give us 6 minus 29 is a negative 23, and so the answer on this one would be no, is what we would end up getting here. It did not balance the third equation. So again, if you did the RREF with the matrices, what you would find out that you would have gotten in the last column would have been different numbers than what we got there. Okay. Number 34, the perimeter of a rectangle is 22. One side is 5 centimeters longer than the other side. Find the length of the other sides, or find the lengths of the sides. Okay, great. So you got a rectangle, x plus 5. So if we add that all up, that would give me 4x plus 10 is equal to 22. And then I would subtract the 10 and get 4x equals 12. So x is equal to 3. So one side is 3, and then 3 plus 5 is 8. So B would be my answer on that one. Number 35, there are 5 women running in a race. How many ways can they finish first, second, and third? Okay, this would be a permutation because order matters. You can't finish first and third at the same time. So this would be 5 women, choose 3. You could also set it up like the license plate problem, do 5 times 4 times 3. Boom, boom, boom. Don't have to worry about the rest of them. That works out to be 60. Either one of those works out to be 60. So we got a string of B's here. Then how many ways can 7 people line up for a play? That is 7 factorial. You get 7 for the first, the second, 6 for the second, third, then 5 for the fourth, third, and so forth, blah, 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 blah. And that one is, if we do 7 factorial, ends up being 50, 40. Now they asked me to write the augmented matrix for here. So remember, we're going X, Y, Z, and then those are my answers. So with that in mind, we see we're looking at a 5x plus 5y plus 3 equals negative 2, 4x, no y, and then we have a plus 7z, sorry, I forgot the z on that one, equals 4, and then 8x plus 9y equals 2. So I'm trying to look at which one of those matches up with those, and it looks like A is the correct match. All right, next one. Which one is the graph? Again, the easiest thing here, since you get to use a graphic calculator, put that in the graphic calculator and see what picture you match it up to be. First off, I'll tell you this much. y equals 2 to the positive x power looks like this. Putting a negative in the exponent means you reflect about the y-axis. So that means our thing should actually be coming down like that, which would be D. The only way that you reflect over the x-axis is if you put a negative in front of the 2. Negative in the exponent means you reflect over the y-axis. So again, put it in the calculator, you can double check. Find the domain. Again, we have a fraction, so we have to worry about what makes the bottom 0. And that's at x squared plus 64. Well, no matter what we put in for x, it's always going to be a positive on the bottom, which means we can actually do all real numbers here. We only have to worry about solving it when there's like a minus sign down there, or maybe it's a trinomial down there. But when we have a x squared plus a number, everything's going to be squared. Every number squared is positive, and a positive plus a positive positive. So there's really no way for you to be dividing by 0. So we get to use all reals on that one. All right, let's see. Next one here, use the graph of f to find the inverse using a dashed curve. Well, technically it's a dashed line since it's a, but again, this one would be, we're reflecting over this. Now you got two ways you can do it. You can either try to marry up and reflect it over doing that, or what you do is where you can write your equation, sort of. It's kind of a little bit more of a challenge to write the equation for that one because we got a decimal y-intercept and x-intercepts. But when I reflect over that line, what's going to end up happening is that point comes down to here. That point comes down to there. So when I look at just the x and y intercepts, so the only one that really matches that would be C. Again, what you kind of think about it doing, if I fold along that dashed line there, then we fold the piece of paper, put it over, then that ends up being where the reflection would be. Use the graph to determine if it is 1-to-1. To be 1-to-1, that means that your if you had two equations, you could say that, like the inverse equation. Here we can use the horizontal line test. If we pass the horizontal line test, then we have an inverse, and then we are 1-to-1. So we do pass the horizontal line test. So we would say yes. All right, so here again, I would graph this in the calculator and see what you're getting is what you're doing here. One way you could rewrite this is y is equal 3 to the negative 1, if you want to call it, to the x, which would be y is equal to 3 to the negative x power. So this is like the one we had up above. This one should be going down from left to right, should not be reflect over the x-axis. And so that would be my picture right there. Again, use the graphing calculator, type it in there, find which one it matches real quickly. Use common natural logarithm. So here we had a problem like this in the first video. I'm going to rewrite this as 1/4 is 2 to the negative 2 power. So this is 2 to the 7 plus 3x equals 2 to the negative 2. Again, now what we can do is we can take a couple of different approaches here. They all have ln in there, is what they end up having. All right, well, oh, again, just a couple different ways. I mean, I personally would have gone with a more simpler way to tackle this one without having to go this route here. So with that, so that's going to force our hand to go ahead and let's take the ln of both sides, which means I can drop this down as front as a coefficient. So 7 plus 3x in front of an ln of 2 equals negative 2 ln of 2. And then well, none of those are going to match up there, so we're going to change our strategy. This is probably one of the ones that's like they choose the most awkward. So instead of rewriting it with 2 to the negative 2 power, let's go 4 to the negative 1 power. So 2 to the 7 plus 3x equals 4 to the negative 1. And then now let's take the ln of both sides. So ln of 2 to the exponent there, 7 plus 3x equals ln of 4 to the negative 1, which now I can go through and pull this over to the side here. If I have ln, I can bring down the parentheses as a coefficient. ln of 2 equals negative 1 times ln of 4. So I can divide both sides by the ln of 2. Divide by the ln of 2. So this gives me 7 plus 3x equals negative ln of 4 over ln of 2. So now we can bring over the 7. So we have 3x equals negative 7 minus the ln of 4 over the ln of 2. We would divide by 3. So divide by 3, and then dividing by 3 would put the 3 on the bottom on the ln. So x is equal to negative 7/3 minus ln of 4 over 3 ln of 2. All right, so which one? There we go. There's what it is. That one right there. Again, not the way I would have chose to solve for x. I think and get it a lot cleaner than doing it that way, but that's the way they chose to have this one for you to match up. So I would pause and go back, watch how I did this, rewind, and how I did that one. Average rate of change, again, they gave us the two x values, so we got to find the corresponding y values and do average. Remember, average rate of change is just slope. So y2 minus y1 over x2 minus x1. So with that in mind, if I do f of 2, that would be 8 minus 10, which is negative 2. And then f of 4 would be 4 cubed, which would be 64 minus 20, which is 44. And then now I find the slope. So 44 minus a minus 2 over 4 minus 2. So that would be 46 over 2, which is positive 23. So that would be my answer there. Again, this next one, 45, is a calculator problem. It's creating your matrices. And first off, before you even go through it, we know we can we can do it because it's a 2 by 2 times a 2 by 2. So we know we're allowed to do it. We have to make sure it's in that order. Again, if you want to, the other way is if you know how to do it by hand. Again, I would put them in the matrices, multiply A times B, tell it what it is. But if I multiply the top row times this first column and do negative 1 times negative 2 plus 3 times negative 1, that tells me the number in the top left cell. So with that in mind, that would be 2 minus 3, which is equal to a negative 1. Well, there's only one of the answers has a negative 1 in the top left cell. And so I'm going to choose that one and move on. Again, do the multiplication in the calculator and you'll notice that it matches up all 4 numbers there. If it did match, if there was another answer, I would have gone through and done the next one, the top right, to find where the first difference was. Do we pass the horizontal line test? Yes, we do. We passed the horizontal line test. So with that in mind, yes, this is a one-to-one function. Find an equation that shifts the graph f by the indicated units. Okay, so great. So we have something to the 4th power, x to the 4th power. We're going to go right 4 up 2. So it needs to be a plus 2 at the end. Well, that means it can't be the first 2. And then right means I need a minus on the inside. And that's all they tell me. So it's got to be B, because D, that tells me that there's a reflection over the x-axis, reflect over x-axis. So, and they didn't say that in the directions of anything, so we know it can't be that one. Use the discriminant to determine how many real solutions. The discriminant is b squared minus 4ac. So with that in mind, negative 2 squared minus 4 times 1 times 2. That's 4 minus 8, which is a negative 4. So there are no real solutions because that's a negative answer. To have one real solution, that means 0 was your answer, and then 2 reals mean that you got some other number different than 0 or a negative. All right, they asked me to write the solution. Well, great. They already did the RREF on a systems of equations, and they got this, and this is my answers, x, y, and z. So 1, 1, and 3. Boom. That was a nice, easy one. Find a symbolic representation for the inverse function. So they want me to solve for the inverse function here. Great. Now, there is a stipulation here because of the x minus 9. We got to be greater than 9. So, so with that in mind, if I rewrite it and say x is equal to the square root of y minus 9, we would square both sides. Squared, x squared equals y minus 9, bring the 9 across. And we would have x squared plus 9 is equal to the inverse function, which would make this. And basically, why do we have to have that stipulation on there? Well, my domain is 9 to infinity, and my range for that problem was 0 to infinity. And so when you find the inverse function, they swap domain and ranges. So this is where our new domain would be for our inverse function. Find an equation that shifts the graph by the indicated units. Great. So that means all I'm doing here is left means I do a plus sign on the inside with the parentheses. Down means I got to do negative 18 at the end. So as we rewrite this, it's x plus 2, and then we do a minus 18. So that would be x plus 2 squared plus 2 times x plus 2. And then we have a minus 7 and a minus 18, which is a negative 25 at the end. So, again, we want x plus 2's, a plus sign, so it looks like A. That looks like, that's right. All the other ones, like here we got minus 2's, we don't want those. This has one of each, we don't want that. This has one of each, we don't want that either. Find the median of the data set. So we got to put these in order. There are 1, 2, 3, 4, 5, 6, 7 items. Median is the number in the dead center. When there's an odd number, it's the number in the middle. So that would be 23. If there's an even set of numbers, we got to put them in order, find the 2 in the middle, and take the average of the 2 in the middle. Again, if you don't want to think about it, a 1 var stat, put the stuff into L1 and do a 1 var stat on L1. Again, you get that by doing stat, and then you go to the second column to calculate, and the very first option there is 1 var stat. And that's where it'll find the mean, the median, the quartiles if you need them, standard deviation as well. In the big bucks lottery game, a person is to pick 4 digits from 0 to 9 in correct order. If a number can be repeated, how many ways are there to play the game? Good question. Again, so you're allowed to repeat numbers. So person picks 4 digits. And you can repeat digits. Well, there's technically 10 numbers. 0 to 9 is 10 numbers. I'm allowed to repeat. And so that would be just 10 times 10 times 10 times 10. And we would multiply that out, and we find the answer is D, 10,000. All right, so use the determined interval where it's increasing or decreasing. Well, we're increasing here, we're decreasing there. Remember, we always use x values. So with that in mind, we have to, this is a graph, so this is the absolute value graph. It's technically y equals negative x, absolute value of x minus 5 is what the graph is. And so with that in mind, we come in from the left, from negative infinity to 5 is the increasing part. So we're increasing from negative infinity to 5. I'm going to zoom in so I can see minus signs. Oh, it looks like they didn't double check this one as I printed this. All right, fantastic. So, because we don't see any negatives in those things. So this one's going to be hard to match up which one they were in thinking of, but we're technically, I would assume this was what their intended answer was. From negative infinity to 5, we're increasing, and then we're decreasing from 5 to infinity. So I think they just left off the negative on that infinity right there, is what they left off with the font. Solve this one again. Your choices are either elimination, substitution, or you could do the RREF and use matrices to solve this one if you want to. The other option you have is take these ordered pairs and plug them in to see which one's balanced. So it's really your choice on what you want to do. So, like, if you wanted to, like, let's go process elimination. If I put 0 in for x, that means I don't have to worry about this part. And then is negative 5 times 8 negative 40? Yes. Is 2 times negative 5 10? Negative 10? Yes. There's my answer. I'm done. Again, here they're asking us to use the determinant. How many real solutions? Again, that's that b squared minus 4ac. Now, this one I'm going to have to multiply it out and then be able to identify what my a, b's, and c's are. So this one I got to do some extra work, and I have to go through and say, okay, what is negative 3x minus 5 times negative 3x minus 5 equal to negative 3? That would be 9x squared. It would be a plus 30x and then a plus 25. That's equal to negative 3. Then we can bring the 3 across, so I can rewrite this as 9x squared plus 30x plus 28. And then now 30 squared minus 4 times 9 times 28. That's 900 minus, that'd be 36 times 28. So 36 times 28 is 1,008. So that's going to be a negative answer. So we're going to say no real solutions on 56. Yeah, that's be a negative 108, so that's there. Again, determine if it's a solution. Again, you can do an RREF on this matrix if you want. Create your matrix, make sure everything is lined up, X, Y, Z's in order, and go 3, negative 8, 1, 0, 2, 4, negative 3, 37, negative 1, 2, negative 1, 2. Or you could start plugging those numbers in to see if they balance. 3 times 7 is 21. 2 times negative 8 is a negative 16. And then minus 5. That would be 0, so it worked on that one. Then we would go through and say, okay, 2 times 7 is 14. 2 times 4 is 8. And then negative 3 times negative 5 is a plus 15. That would give me 37, and that's equal to 37, so that worked. And now the bottom one, negative 7 plus 4 plus 5, are you 2? Let's see. That would give me negative 7, negative 7 plus 9, that's 2. So that balance. So yes, it is a solution. All right, identify any horizontal asymptotes on this one. Well, horizontal asymptotes is basically, is it approaching a line and not going above it? So to me, there looks like there is a horizontal asymptote is what it's approaching on for both sides. And with that in mind, if we think about this, this is 1 5/7. Well, we don't go above y is equal to 1, so it can't be that answer choice. That looks pretty good. That's approximately 0.7, 0.7 something. It's a 6-digit repeating decimal. That's not too bad. Y equals 0, that's the x-axis. So it can't be that because we were far above the x-axis. And here it says none. So I would say your best option here would be B. What's this one to ask? Still horizontal asymptotes? Yes, horizontal asymptotes. So it looks like we're coming across maybe somewhere out this way a horizontal asymptote, and maybe one this way here as well, is what it looks like. Now you're allowed to cross a horizontal asymptote, is what you're allowed to do. Now, it'd be nice to have a bigger picture. We're not approaching 9 or negative 9. We're nowhere does there look like it's approaching negative 9 or positive 9. But we do see here that it is coming down to flatten out this way. So we're going to say there is one, so we're going to rule off the none and say the answer is A. And we will finish up this page, and then that'll be the end of the video here. Find the inverse. Okay, great. So finding the inverse means we write the problem down. Now, we're supposed to rewrite it and so forth, but again, in order to have an inverse, you got to pass the horizontal line test. If we think about this, this is a parabola, and it does not pass the horizontal line test. So it's not going to be 1-to-1, especially since they didn't restrict the domain here. So on this one, we're going to stop and say not 1-to-1, because we can go about solving and figuring out what it would look like, but technically when it doesn't pass the horizontal line test, it's not a 1-to-1 function, especially when they don't restrict the domain. Here, we're saying, hey, only from like 0 to infinity. So next one here again, you can multiply the two matrices. Yes, it's a 2x2 times a 2x2, so we're allowed to do it because the middle two things matches. I'm going to do the same thing. I notice they all have a different number in the top left-hand corner. So I'm going to take the first row times the first column, and it would be 3 times 0 plus negative 1 times 2, which would be 0 minus 2, which is a negative 2. And that means it's got to be that answer. To me, again, time-sensitive tests is just easier for me to go through and do that. Again, I would go ahead and create your matrices, let it multiply, then you can match it all up. Especially if there's more than one that has more than one element has the same number. Last problem for this video, specify the domain of the function. Well, we got a square root, and I would graph this. And so when you look at the graph, what you would notice is that the graph is technically starts at 10 and it goes this way. So that's telling me that it's everything less than or equal to 10. And again, it's okay. We can take the square root of 0, so it's okay to have that on there. And so, again, I'll graph it, take a look at it. I'm going to do it real quick before I get off this thing to see how many problems are on here, just so I can decide if we want to do a few more on here. There we go. There, and I left the answers down there in case you need it. 98. Now let's do it. Let's do the next page and stuff. Let's do the next page. And there we go. All right. Again, find the discriminant. That's an easy one to do. We've already done it a couple times. B squared minus 4ac. So negative 10 squared minus 4 times 1 times 25. That would be 100 minus 100, which is 0. That means that there's one real solution. Again, if it equals 0, one solution. If it's some other number, some other positive number, then it's two solutions. And then if it's negative, then it's no real solutions. Solve the equation. Again, we should have two answers here. So first thing we do is always move the 8 or the numbers outside the bars before we start setting up the problem twice. So I'm going to subtract the 8, and we get the absolute value of 4m plus 3 is equal to 9. Now we write the problem down once the way we see it, and then we change it to be a negative 9. Don't change the stuff inside the bars. Subtract the 3. 4m equals 6, divide by 4. M is equal to 3 halves. And it's a positive 3 halves, so that means that's my answer. We can double check that by bringing over the 3. 4m equals negative 12, divide by 4. And we get m is equal to negative 3. Again, this is a calculator activity here. Put it into your calculator, the 2x2 matrix. Again, remember, you can only do the inverse of a square matrix, so we're allowed to do this one. And then I would let the calculator do all the work for you. Once you create it, get the matrix A on your screen and do the -1 power. And then you can match the answers there. I'm just going to go ahead and tell you the answer here. It is C. Remember, after you do that thing, do math, enter, and it turns all the decimals into fractions in each of the locations. So here we're just matching up a which scatter plot with that set of data. Again, take your time, pause the video, just start matching up 0.44 and so forth, and ruling out certain ones. So like I only see. If I zoom in, I see 1, 2 with negative y values. So there should be 2 below the x-axis. Well, it's not that picture, because that has a bunch below it. That has 2, so that's a potential. That has 2. This has none. So I've just ruled out 2 just by looking at those things. Now let's look at the x values for those two negatives, 0.11 and 0.52, which means I'm to the right of the y-axis. So that means that is my answer. They're both to the right of the y-axis there. So that's the way I figured out was the fastest, was how many are below the x-axis first, and then 2 below and to the right. And there's a stopping point. All right, so again, I'll put out another video on number 3.